Hey, welcome to The Explainer. This is where we take really complex topics and, break them down using the source material itself. And today, we're going on a journey, diving right inside the mind of a large language model. It really can feel like magic, can it? You type a question and this coherent, sometimes brilliant answer just pops up. But it's not magic, it's actually a fascinating process. So, okay, let's pull back that curtain and actually follow your prompt on its journey from your screen deep into the core of an AI.
All right, so the very first thing that has to happen is a kind of translation. See, the model doesn't understand English or Spanish or any human language. It speaks the language of math. So your words, they have to be converted into numbers.
This first step is called tokenization. Your sentence gets shattered into little pieces called tokens. And it's kind of weird, right? You can see how have the bards is broken down. Even a single word can get split into smaller, more common parts. Then each and every one of those pieces gets a unique number, its own token ID. It's like a secret code, the first step for the AI to start understanding what we're saying.
But, just having a bunch of ID numbers isn't going to cut it. The model needs to get the meaning, the context. And that's where embeddings come into play. The best way to think of them is like GPS coordinates, but for ideas. In this gigantic, invisible map of language, words that mean similar things, like, say, king and queen, their coordinates are going to be super close to each other. Okay, so now our prompt isn't just words anymore. It's a set of these super meaningful coordinates. And right here, at this point, the process forks. One of two specialized minds is going to take over, depending on what we're actually asking it to do. Think of it this way. You've got the analysts, and you've got the creators. On one side, you have representation models. These guys are brilliant, super fast analysts. Their whole job is just to understand and classify information. On the other side, you have the generative models. These are the creative authors, the ones built to write totally new text from the ground up.
And this diagram just lays it out perfectly. Look at the top flow here, a representation model. Our analyst might take a phrase like, best movie ever. That's a sequence, and its output is just a single value, like the number 1 to mean positive. Now, contrast that with the bottom. A generative model takes a sequence, like your question, and it outputs a whole new sequence of words, your answer.
All right, let's put that analyst model to work. Let's say we have a classic problem. We've got thousands, maybe tens of thousands of movie reviews, and we need to know, like right now, which ones are good and which ones are bad. This is a perfect job for a classification model. And this is where things get really, really clever. Training one of these huge models from scratch can cost millions. So instead, we can take a massive pre-trained model, that's the frozen part of the iceberg, that already gets language, and we just train a tiny little specialized classifier right on top of it. It's an incredibly smart and efficient way to get an AI to do a new job without, breaking the bank. And would you look at that? The results are pretty darn good. Now, we're not going to get lost in all these numbers, but that final F1 score of 0.80, that's the real takeaway. Think of it like a final grade. It tells us our AI is doing a great job of balancing everything, catching all the good reviews without messing up and flagging the bad ones. And 80% is a solid B, which is fantastic for this efficient frozen model approach. Okay, that was the analyst. Now let's switch gears and talk about the other mind, the creator. The big challenge here is stopping these things from just, making stuff up. How do we keep them grounded in actual facts? Well, the solution is a brilliant technique called retrieval augmented generation. We just call it RAG. And I love this analogy on the slide because it's perfect. It is exactly like giving the AI an open book exam. Instead of asking it to remember a fact from its millions of data points, we just hand it the textbook with the answer right before the test. This makes sure its answers are based on specific, real documents. So how does this open book test actually work? Well, it's a super clean 3-step play. First, the system retrieves the most relevant facts it can find from a specific knowledge base. Second, it augments your original prompt, basically stapling those facts to it as context. And finally, and this is the important part, it tells the model to generate an answer using only the information it was just given. But you might be wondering, how does it find that one perfect piece of info in a giant library of documents? The secret sauce is something called chunking. Instead of making one giant GPS coordinate for a whole book, we break the book into smaller paragraphs or sections, and each one gets its own coordinate. It makes the search process way faster and way more precise. And boom, here's the payoff. We ask a really simple question about the movie Interstellar. Income generated?
And because the RAG system finds that specific little chunk of text and feeds it to the model, we get a perfect factual answer, pulled straight from the source. No guessing. Just facts.
Okay, wow, that was a whirlwind tour, right? So let's take a step back, zoom out, and put together the final blueprint of this whole journey, from your keyboard all the way to the AI's final response. This right here, this is the mental model you want to walk away with. It's a really logical pipeline. First, we tokenize words into numbers. Then, we embed those numbers to give them meaning. Next, the model processes that meaning, either to analyze or to create something new. And finally, that output gets applied to a real-world task. Simple as that. So we've got a blueprint for how these things work. We get the mechanics. But that leads to a much, much bigger question, doesn't it? As these tools become unbelievably powerful, how do we make sure we're deciding what they should work on and why? That's not just a technical question anymore, really. That's a question for all of us to think about.